If I sit down for this one, and thank you, Chapon. I think we should keep that. It's the first of these tutorial workshops, and we should keep that quite informal. So please stop me at any point or ask questions. Maybe during the talk if you have a very pressing question. Otherwise, we can talk during coffee. Just to say that I'm just a messenger here, and all this work actually, including the slides, this is work from Juan Rodriguez Carvajal, who is my colleague and group leader of the crystallography group at the LL. And I've done very little in all this work. I'm just a user like most of you or some of you. And so I will go through the features of FullProf, which I think would be interesting and maybe also slightly different to other programs. I mean, I don't think there's always competition between different programs, but I think the important thing is to use them for what we're good at and for, you know, if they solve the problem for you. So the reason I use FullProf myself is because I'm looking mostly at magnetic scattering and commensurate magnetic structures, and this is one of the things that FullProf has always done, and also working with single crystal magnetic scattering, including polarization analysis and things like that. So FullProf is developed by Juan. It's a very large collection of software suite. It's not only a middle program, but you can also treat different type of system, including single crystal, as I just said. I think one of the first things, if you start, and certainly the people that are interested in attending the tutorial later on, is to visit the website. Essentially, the best way to do it is to Google for FullProf and ILL. And if you do that, the first hit you get is going to the FullProf webpage. And you can download the software from there. It exists for Windows, Linux, and Mac. The Mac version is only for the recent version of the Mac, the Intel processor. And there are slight differences between each version, but essentially the core engine is the same. And you have some installation notes here, how to install it on different systems. So I suggest that at some point before we start, if you're interested, just do that. Another interesting thing is here the presence of example and tutorials. And Juan has a very good habit of putting tutorials as zip file that comes from different workshops and schools. And usually in these tutorials, you find input file, you find data file, and also a very short PDF presentation of what needs to be done and the different steps. So you can certainly look at that. You can also download programs individually here if you go to programs. Okay. So FullProf is, so we went through that. There's a very large collection of programs, and the best way to access all this program at the moment in FullProf is to use what is called the FullProf Toolbar. This was not present a few years ago for people that used FullProf in the past and stopped using it. Essentially, this is a unique system, but you will start that from an icon on Windows, I guess. This is essentially a toolbar which gives you fast access to all the different programs in the FullProf Suite. So in there are different things. The engine that allows you to essentially visualize quantum diffraction patterns as well as the result of refinements and so on. You can do individual peak feeds, whether it's time of flight or constant wave and neutron or X-ray diffraction. And it has also interface to other programs. So this central piece of the software is called WindPlotter, which you can access on the toolbar here. You have two versions of it, which is always makes people laugh. You have the white version, which doesn't work on Linux, it's only a Windows stuff. This was developed before FullProf was essentially deployed in many platforms. So if you have Windows, this tool you can use. Otherwise, you have the green or the blue wind plotter for Linux. And this is essentially where all the plottings and where you can zoom and do also connect to other programs, for example, indexing programs such as Tray or Digvol and Little. So that's a central piece of the toolbox. Then FullProf itself is just the refinement engine, and with that, as I already mentioned, you can do Pounder, simple crystal. Recently, Juan has put quite a lot of effort to implement polarized neutron and also simulate annealing to solve in particular magnetic structures. There is one editor. So FullProf typically, we will see later on, maybe in more detail, you can access, let me see where the tutorials are. So you have an input file. This is essentially a text, unformatted file. This is the way FullProf historically has developed. And so you have your data file, which is essentially an ASCII file or some whatever format. It can be binary as well. But the input file is essentially text, free format text. But recently there was an addition of also GUI. So the GUI is called edit PCR, which is essentially an editing PCR file. And you can access that from this here. So if I take something like that. I don't use it myself, and I will not use it in the tutorials, just because it's for some reason I started before the interface was there. And it's the opposite for Jesus. I started using Jesus after, when the interface was already implemented. So I use the interface in Jesus, but not so much here. And so from this interface, you can access essentially the different phases, refinement, procedure, background, and so on. Click, push button way. You have also a lot of other programs to display the result of, I think there were questions about that the other day about Fourier maps. This is available on the toolbar here, G-Fourier, where you can explore, at least in 2 dimensions, you can cut through maps in the unit cell. You have number of tools where you can look at bond valence sums, distances, angles, and so on, which is essentially post-analysis tools. You have also utility to do supercell or look for modulation vectors, propagation vectors, such within the toolbar. And maybe I will go through that if we have time later on. One of the good things in FullProf is there is an implementation of is a program called BasirRep, which is essentially calculating the irreducible representation of space group in the case for structural displacement and also for magnetic nodes. And this is done with the program underneath is called CAREP. And essentially from that you can calculate a symmetry adapted displacement mode, whether they are structural or magnetic, and then plug this symmetry adapted node, which belong to different irreducible representation of the group, inside inside FullProf for the basis of your refinement. You have also access to FullProf Studio, which is essentially this icon here, where you can display structural and magnetic structures, including any commensurate magnetic structures, very complex modulation, and so on. And then a number of utilities. I will probably not have time to go through all of them, but things to check groups, to program to actually reduce data coming from different single crystal instruments, and so on. So essentially, the central piece of the engine essentially is FullProf, and the input. So we went through all of these. So when you start the FullProf toolbar, where it is now, the first thing you have to do is go in settings, and then here you can configure what is your preference as an editor, for example, as a web engine, and so on. And then you can save these preferences. It's quite, people like different editors with color editing and all these things. It's a good thing to do that. And if you don't do that the first time, FullProf will remind you that you haven't done that. So that's the first thing to do. Once you've done that, you can essentially do the new way to run FullProf is essentially to select a file or a directory where you're going to work, for example this, and then once you've done that, in the toolbar there is something actually that indicates which file is currently loaded, if it's the input file, the path, etc. And from that you can directly have access to either plotting or refinement or visualization of the field and so on. For example, I can just invoke the FullProf program by clicking that. It asks me what the data is, because I didn't say what the data is yet. And then go through that. Okay. You can plot directly what you've just done by pressing the with plotter button. So as long as you define a path and which file you're working with, then all the other programs are automatically connected to this particular file. So for example, if you were to do a difference Fourier map with this particular file, and then you wanted to have access to the Fourier map, you would just click on this button and it will be done. Okay, so it's always trying to look for essentially the same file name that will create a different extension. So that's the way it will work. And also if you load that, then you can directly invoke the editor where you can change, etc. In the editor, one of the convenient tools is to import data from a zip file. So essentially, you just take the zip file and it creates a PCR for you. You save it and exit the editor, and you can run. Okay, so that's the main way to use FullProf nowadays. People like me tend to use it from this, just editing the text and doing it much more quickly. So whatever your preference is. Okay, so we went through that. So there are a number of tools that you can use directly in FullProf, which are not necessarily related directly to the refinements, but they're external tools. So for example, if I take back the refinement that I've just done, so this is essentially, maybe if I plot something else. So this is one of the tutorials that we can do if we are interested this afternoon. So this is a thallium fluoride sample. This is here some data collected from neutron scattering on the with pretty good resolution. And the structural information, so that's been collected at 5 Kelvin. The structural information in this case is fixed, and another data set has been collected on a different instrument, on a cold diffractometer, to see the magnetic scattering. So all the peaks that you see here, for example, that have no intensities, they are magnetic reflections. So you have tools in FullProf to automatically detect peaks, like you will have in any programs, I guess. So for example, peak detection, enable that. So I can have an automatic detection of all the peaks. In this case, I want to have an automatic detection of just the satellites, which means the peaks that are magnetic in origin and that have not been yet included in the refinement. So you can do something like that. There are threshold criteria of a number of iterations and so on. And then essentially this will try to detect peaks within the criteria that you gave that were not indexed before. So you can see this one is correct. These two are correct. There's one missing here. You can insert manually, I guess. This one, okay, there's probably another one here. These guys, I'm not quite sure they're magnetic. So you can delete that. And then you can do that also with all the peaks, not just the satellite. You can save this peak in a different format. For DigVol, for example, ITO or Trail for auto-indexing program. And in this case of magnetic satellite, you want to save that as a format for searching for wave vector. Okay, so this is called This is essentially a grid search, where you essentially search for the wave vector in the grid, in the first gradient zone, for example. So it picks up, because you define everything in the toolbar, for example, you define the file that you're working with, it will pick up the lattice parameters and all the information that it can pick up from the PCR file. So you don't have to reintroduce that. This is why it's so important if you use FullProf nowadays to use the toolbar, because everything is connected. So in this case, you can say that, for example, you can search only for special k vectors. It essentially means high symmetry point of the gradient zone, or you can just relax that. You can search in the full gradient zone, for example, 100 by 100 by 100 points. So it will be a radian point in the reciprocal space. Say that. Let's call that test 2. Like to run things from the command line. And then you can run k-search, which is an external program. You can run all these things directly. If you run Windows or Mac, you can run all this program directly from the interface as well. Test 2. So this is doing a million point in the cell. And of course, it will always be fine in this case incommensurate propagation vector, especially small ones, because it will index everything. But it's still quite clever. For example, telling in this case that it's probably a special k vector, which is 001. And actually, that's the right one in this particular example. You can do exactly the same thing as I did there with all the peaks, not just the satellite, and then invoke ITO and Treo and so on. Okay, so you can also make individual peak fits. So when you have a pattern like that, I haven't done it on this particular example, I hope it's going to work. So where is my nuclear phase for this? Yeah, so I think like that. Well, actually, this is maybe something you can do only from the old Windows version. Yeah, this is something you can do in the blue WinPlotter. But you can essentially refine individual peaks and set the same them as well. One important thing in FullProf is wherever you install FullProf, for me on Unix, it's going to be in the local. Let's see where this is. Use the local. When you install FullProf, wherever you put it, it will come with a number of examples that you can run through to help getting familiar with the program. It will also contain a directory which contains instrument resolution function files. And essentially, this file you can see a lot of files for different institutes, DLL, through slide source, the SRF, ARM, and so on. And essentially, in this file, you will have the resolution function of different diffractometers. So essentially, in the FullProf input file, the only thing you will find is the additional parameters. For example, if you have microstructural effects, it will be always take into account the resolution function as long as you've given one. The same thing if you do individual peak fits, it will ask you to provide an instrument resolution function file. So that's one thing to look for, and if the instrument that you are interested in is neither very simple to do yourself or not in the list, then usually one is very good at including new beam lines and new resolution function if you ask him directly. Okay, of course, as I said, there's a number of programs that are accessible from the library here. There is also tools directly in FullProf for cyclic refinement. So if you go in there, you have something called FullProf cyclic, and the only thing it's asking you to do is to select the PCR file that will correspond to your first input. So essentially, let's say you've done a refinement at room temperature, and you have data from room temperature up to 1000 Kelvin, and you want to refine all of this in an automatic way. If it's quite easy and there are no structural phase transition and so on, then you essentially select your first file and then the code for the data file and the first number. So for example, if I had I don't know, a D20 file called D20 underscore 123 56 to 123 and dot dat. So this will read D20 underscore 123 56 dot dat up to D20 underscore 123 dot dat and just refine them. And then you have different options. You can save all the plot for all the files. You can save HKL files which contain integrated intensities, agreement factors, and so on. You can save also distance files where you can look at bombarded songs and so on. So this is directly accessible from that. And there is a button next to it to plot the result of all this sequential refinement. So very quickly, for example, if you follow the temperature dependence of a magnetic moment or temperature dependence of a particular thermal parameter, you can do that directly from the interface. Okay. Yeah, there is a lot of tool also in WinPlotter now to be able to plot essentially with OpenGL, so accelerated graphics, a very large data set. So if you have again 1,000 data set or something like that, and you want to plot that as a function, either as a false color plot or as a three-dimensional plot, you can do that directly in WinPlotter. I don't think I have one here, but essentially what you do, you open a buffer file, and a buffer file is nothing else than a text list of your data file. So if you have, again, D20.123 up to D20.256.dat, you just put them in a text file with whatever preferred program that you have, and you open this buffer file of FullProf and you plot it in 3D or in false color plot. Okay. We can go through that and create buffer files in the tutorials if you want, but it's nothing very fancy, everybody can do it on its own. This is an example where you have different magnetic ordering of copper and aluminum at different temperatures. Okay, just a few things I wanted to, which I think are very convenient. So essentially, FullProf, maybe I should explain that a little bit. It's based on Fortran library, so everything in FullProf is written in Fortran 95. It's based on a Fortran library called CrisFMR, which is cryptographic Fortran mathematical library. But one has built over the years and also translated a lot of the old code into this library. The library itself is not open source in the sense that it's not GPL licensed or LGPL licensed. But if you are interested in developing, it is actually open source in the sense that there is a subversion server that one will be very happy to give you access to if you wanted to either participate or fix bugs or whatever. So it's not really released as an open source, but it's completely open in the mind of one. There's actually quite a lot of effort, I think, at the moment from, for example, the SRF, that is doing Python wrapping around some of the modules. Again, this is available. All the GUIs are essentially separated, of course, from the kernels, and the GUIs are done with a Fortran program which is called Winteractor. And again, any help in there is always welcome. So typically, input in FullProf is very easy. You have an input file, PCR, a data file, and then you crunch it, and then some output. The PCR file, I will admit, if you don't use the interface, it's quite a steep learning curve, because also you can do a lot of different things. And I know that people usually struggle, in particular when they start on magnetic structures. How do I do something incommensurate? How do I define this? How do I do rigid body? There's so many things that it's a bit difficult. So I think we'll go through some of the basic in the tutorial section later on. But most of it, I would say, is pretty self-explanatory. For example, you can recognize your usual UVW, guillotine parameters. You can lattice parameters here, symmetry parameters, the atoms position, thermal parameters, and so on. Essentially, in this PCR file, everything that's starting with exclamation mark is a comment, and you can put as many comments as you want. And the rest is automatically formatted. So, for example, if I didn't want to refine this parameter here, which is has a certain code, so there's a convention in FullProf that this thing is parameter number 8 will, with a shift of 1 will become 81. So if I didn't want to refine this guy, and I didn't want to refine this guy, I don't need to go there and essentially remove it by hand like that. You can take the full line and put a 0 at the beginning. And you can still run FullProf, and when you return to the file, it will reorder all the coefficients for you. You don't have to respect the number of zeros or the numbers of the parameters and so on. And essentially, as long as you are in this mode, is very important. This was not the case a few years ago, but there is an automatic mode. And this automatic mode here essentially will relabel all your parameters, so you will never end up with a matrix with zero, with a non-defined singular matrices, essentially. Okay, I think it's like 10 minutes to go before coffee break. The data files themselves are very easy, and if you have a data file that is not already readable in FullProf, then I think the data file themselves, you can see, you have a free format, that's essentially XY error, different ISO format. You have things like GSAS, also cost of web vector, GSAS time flight, analytical format, etc. If it's not in there, just please ask one, and it will be there quickly. But I think a lot of the standard things are already in there. So the interface itself, the GUI, I don't use it myself. Please have a look. It's quite, everything is relatively well explained in there. One thing I wanted to show you, because maybe we would not have a lot of time to do that later on, is the use of BASIREP for representation analysis. This is something that I use a lot personally. So if you go to the FullProf toolbar here, this is BASIREP, and it's very simple. Just create a new file. I like to call everything text, so I end up with text everywhere. Title, we don't really care. Test title. Space group, I don't know what we can take. A wave vector, so it can be center of the zone, 0, 0, 0, or anything incommensurate. Take something sample, R0. Whether you are dealing with polar vectors, so axial structural displacement, or whether you're doing the axial vectors. We will see on Thursday that magnetic moments behave like, well, we transform like axial vectors. But let's say we want a polar vector, the number of atoms that you need to consider, the symbol of each atom and the position. Oops. Put that general position, and then you just run it. And I don't know if you see very well. You can open that with another editor. If I can find it. We call it test, you know. So it will start with the group, the full group symbol, the Lowry class, the general multiplicity, and so on. So some information about the cell, the different symmetry operation that you have in this particular group, different Wyckoff position, and symmetry, and so on, and then the number of generators. And eventually, if you continue to go down, it will tell you that the wave vector you chose was 0 out of 0. And then you will see, I'll skip some of the output, but you will see here all the symmetry operators, identity, 2 4 axis along Z, y, x inversion point mirror planes. And for this, all of these symmetry elements, the character, so the different irreducible representation of the group and the character of the representation. And for those of you that use symmetry, then it's a very convenient tool. I mean, we all use symmetry, but symmetry in the sense of, for example, looking at phase transition, whereas symmetry adaptive mode is very powerful tool. And then it will tell you that for the atom that you chose, it will label all the modes. So this is, for example, the mode of the representation gamma 4, and this is for each atom the relation between the atomic displacement constrained by the symmetry of this particular reducible representation. It will also generate a file which is essentially directly can be copied. So for example, let's imagine I want to test the representation gamma 2. I can copy this block and put it in the PCR file, and it will constrain all the symmetry for you. And you can do that for structural modulation and magnetic modulation as well. So that's quite an important tool. Okay, maybe this. So this is a tool where you can essentially look at bond balance sum. This is called bond STR, and again, it's accessible from the FullProf toolbar. And from that, you can essentially look at number of neighbors of a given ion, distances, enteratom distances, angles, and it will read also directly from this zip file and generate that for you. So if you wanted to make sure that there's nothing fundamentally wrong with a given coordination unit, then you can do that here. I think we're running out of time, so just one important thing if you use FullProf. The way that Juan is keeping his community informed of changes is to put all the changes in the file which is distributed in FullProf and that is available also on the web. It's FullProf 2000 or FullProf2k.inf. And in there is pretty much every week or so there is an entry of something that has changed or new features or something like that. And not everything, I think it's fair to say that when you're doing software as part of your spare time, because I think not a lot of people in the world are paid to do just software. There are a few, but not a lot. It's fair to say that the documentation doesn't always go as far as you would want it to go. So the best way to look for new features is to look in this file. For example, if there's a new feature with rigid body, it will be explained in this file and how to use it and so on. And I have only 5 minutes, so I just want to show you something else which is very recent. And so rigid body. There is, I don't have much experience with that myself. I've just seen it working, but I haven't used it. There is a new rigid body constraint in FullProf that you can use, and you will have access to the files. And I don't know, I've never used it myself. One thing I use myself and I found extremely powerful is the connection that they have done with the Bilbao cryptographic server. So again, the idea here is that if you have a structural phase transition and you go from a high symmetry phase to a low symmetry phase, and this transition can be described essentially, or like the framework of Landau theory of phase transition as a condensation of different modes of particular symmetry, you can go directly on the Bilbao crystallographic server and use entry mode directly for your refinement in FullProf. So if I look for Bilbao crystallographic server, there's a lot of tools, as probably some of you know, and one of them is ampli mode. And if you click on ampli mode, at the top here, there is something for the FullProf Suite. I know it's something very similar at the moment in Topaz, where, for example, Topaz now, in Topaz you can start to do magnetic structure determination also. And there is a link between the isotropy software and Topaz, so you can directly do the same thing as you can do here with ampli mode. So here you put your high temperature structure, for example, in this case, the variable titanite, cubic. You can put the low temperature structures even without any atoms, just the lattice cell of your low temperature structures. And then essentially show all the symmetry adapted mode. So for example, for this oxygen, you have a gamma 4 minus, a gamma 5 minus representation that can be involved and so on and so on. And once you've done that, you can click here and you will generate automatically an input file for FullProf. And what you do in this case is that you refine, you can see here, the structure in its ideal high temperature cubic form, but instead of refining atomic position, what you refine is the deviation, if you want, from this ideal symmetry, high temperature symmetry, with the different modes, which are normalized modes of the high temperature structure. This is extremely stable, in particular when you are very close to phase transition. And this, I've seen a demonstration of this running recently from one Manuel Garazmato. And if you follow, you have a lot of data sets with a structural transition that is continuous at the transition. And refining this mode, you will see very, very nicely not only the primary modes of the phase transition, but also the secondary modes that are starting to come in at lower temperature and so on. And I believe this is a very, very intuitive for the people that use symmetry. Very intuitive way to do it, but also a very good idea to do that in a more systematic way. So yeah, this is just the format. This is a new job type. That's the kind of thing you will have in this info file. And here you can see the structure is defined in its parent structure, and what you will find is all these nodes which belong to different irreducible representation. And once you've done that, in this case there are 12 different polar modes, and you have all the coefficients for that. I'll skip all the. So this is an example of the refinement converging all the modes involved. And once you've done that, you can directly plot the different modes either independently or combined together in FullProf Studio. So for example, here you can see all the tilt mode, the rotating mode of the octahedra, and you can combine all these modes together to create either an average structure or to look at them individually. And to say, okay, that's a primary mode, this is a large distortion of my structure, this is a more smaller mode, a secondary mode, and plot it like that. Okay, that's where I stop. I think that's.
Thank you for the nice lecture. We will have a workshop today, both on GSAS and FullProf, so actually I want to initiate a little bit rather discussion of some things of a general interest rather than asking some technical questions specific, which you can ask later actually during the workshops. First I want to make a little comment that actually this green version of Bitplotter, you can make peak filling, but if you open not the PRF file, but that file.
Okay.
Then it activates the yeah. But that's a technical thing. And more general, what I would like rather to hear is, well, it was very nice, I just learned actually from your presentation that now the rigid body has a much broader support. Because that seems to be like the major problem for users. There's actually many like aromatic rings, etc. They are not pretty flat. Because constraints with angles and bonds doesn't let you. Well, if you constrain them too much, if you really insist that they're flat, then the function is not stable.
Yeah.
So, and the real rigid body, which is a true rigid body, without constraint restraints, is so difficult.
Yes.
It's made it so complicated.
So as you know, I mean, all these software are always developed with the mind of the developer, and it's clear that one has a lot of, has had in his career a lot of interest in things like magnetic diffraction and manganites and these things, and he's pushing, of course, always the things that are more natural for him. So I think it's fair to say that the rigid body has never been at the level that you can find in all programs, and so be it, that's fine. The only thing I've known is that recently there's been an effort to improve that, but I can't possibly comment on how good it is because I've not experienced myself, so this is something to...
Yeah, that's something to study.
Just to study, yeah.
Another thing is this amplitude, which is perfect. Well, magnetic scattering, of course, FullProf is kind of leading and the best and the first to do the things, but it's very complicated because it's a proper symmetry analysis, which is done. Well, one has to have a lot of understanding actually to do it.
Well, magnetism you can do in a lot of software. GSAS does magnetism very well with Sherikov groups, at least the version that they use, GSAS 1. And this is perfectly fine as long as the structure is commensurate and can be essentially described by a one-dimensional real representation. I think Toolbar now can also start to do commensurate magnetic structures, so again, there's no reason to use it, not to use it, sorry, if you feel it's adequate.
Well, while magnetic stuff is quite specialized, few people use it probably from the audience. Amplitude is something that applies well to nuclear structures.
Yes, amplitude is something that is very powerful because, of course, it's connected to the Landauer theory of phase transition, and we know how powerful this theory is and has been for the last 60 years, 70 years. Yeah, I believe this is a much better way to look at phase transition than to, to decompose atomic displacement into symmetry adaptive modes. Because first of all, you can classify and really see what is the primary or the parameter of the transition, which means the leading displacement, and also deconvolute that with secondary effects, secondary modes.
It's also kind of a parametric ritual refinement, but
yes,
it's not for the multi-pattern. It's within one pattern, but you group parameters actually. So it's kind of also parametric because you create a model. Yeah. So there will be any comments from the audience? Yeah.
Are you suggesting that we should use other softwares for organic and metal-organic compounds, if I understand?
Well,
well, you were saying that the rigid group parameters and restraints are not the best. You can find better.
Which I received from other people were mostly about the rigid group. So if this part is now improved, I would say closest like the more difficult.
Okay.
The one thing that I forgot to mention is that now every year there is a FullProf school, which is usually around March or April at the LL. And the school is split in two parts. The first week is beginners, where you essentially learn about FullProf in general. And the second week, or the second part of the school, is really specialized in one area. So one year it will be magnetic diffraction, another year it will be rigid body, and so on. So I cannot comment on rigid body. Again, I haven't used it myself in conversion. But you should watch out for these schools. They're pretty good at trying to get up to speed in a given area.
What about models for preferred orientation? Do you have marsh delays and spherical harmonics?
Again, it's not something that I use personally a lot, but it's in there.
Yes, because FullProf belongs to my beloved programs, I wish to tell you that the rigid body part was fully functional almost 10 years ago. Actually, I used it approximately by the time, and the setup was not very tricky. It was quite easy, but unfortunately, it wasn't described. But when I asked Juan, it explained it in 3 sentences. This is really that easy.
I think the part that was missing, if I'm, the part that was complained about is I think at some point they wanted to make an editor, for example, to make it, to essentially define very in a click and push kind of way the rigid body that you wanted, and have a nice visual representation of that. And I think that's the part that really improved. But again, probably it's better to ask Mark directly about that.
Okay, thank you.
More comments? Questions? Do you want to add something?
Oh, I just want to say that for this afternoon, it's a bit difficult to know what we're going to do. We don't have computers for everyone. I guess people have laptops. There is a lot of tutorials on the website, and I'm happy to go through any of them. But people can do different things. So we'll have to see how it works, really. I guess if people just want to have an introduction, we can do that. If people have their own problem that they want to look at with FullProf, we can try to do that, even though it's going to be difficult with just one tutor going through everyone. If people want to solve one magnetic structure in their life, and it's the last one, the first one and the last one, I'm happy to go through that, but it's a bit more difficult because we haven't been through the formalism yet. It's going to be defined, I think, a little bit at the last minute. But there is a number of tutorials, and we'll see how it goes and how many people are in the session.
Thank you. So let's end the speaker again.